Hello everyone and welcome to day 3, which is on rectangles. Start off, we've got this theorem that says if a parallelogram is a rectangle, then its diagonals are congruent. So remember that the diagonals are the lines that go through the rectangle like this and connect the opposite corners. So those are diagonals. In a rectangle, specifically, those are the same length. Keep in mind that this also says that in a parallelogram, which means rectangles are parallelograms. They have all of the same features of parallelograms, and we'll see some of that in example 1. It says a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging, and it gives us some lengths. It tells us that JK, this measure right here, is 12 feet, and then it tells us that LN, this one right here, is 6.5 feet, or 6.5, and we're going to find KM. Let me make that a different color really quick, so that'll be green. 6.5. We need to find KM, which is this other diagonal. I'll make it pink. Going this way. To find that length, remember that the diagonals are the same. So if I know that this half of this diagonal, LN, this part, is 6.5, that means that this half is also 6.5 because in parallelograms, diagonals bisect each other. So I'm going to write that over here. Diagonals bisect. That's just a feature of parallelograms. And a rectangle is a parallelogram. Therefore, it applies to a rectangle. But what's special to a rectangle is that the diagonals are congruent. So, since the diagonals are congruent, if I find the length of JL, my green diagonal, I'll have the length of KM as well. So, JL is made up of two halves, which are 6.5 and 6.5. So, if I add those together, I'll get the length of the whole thing, which is 13. So, JL is 13. And since those are the same length, KM is equal to JL, so KM is also 13. Moving on to example number 2, we've got another quadrilateral here that is called EFGH, and it is a rectangle. We're told that it's a rectangle, and it gives us GH here. This problem right here tells us that's 6 feet, and that FH, this whole diagonal is 15 feet, and we need to find GJ, which is, let me grab a different color, this diagonal right here. So remember, the diagonals are the same, which means all of their halves are the same. Because if all of the lengths are the same, then if you cut them in half, all the halves are the same. So this half is the same as these two halves and this half. So what's half of 15? Well, 15 divided by 2 is 7.5, which means that this half is 7.5 and this half is 7.5. And wait, all the halves are the same, so this half is also 7.5. So GJ is 7.5. Okay, next example, we've got another quadrilateral that's a rectangle. This time it gives us some angles. First one is RTU, which is this angle right here. It tells us that that is 8x plus 4. And then it gives us another angle. It tells us SUR, which is this angle, is 3x minus 2. Okay, so remember in rectangles, these diagonals halves are the same length, yes? So if I make a triangle using those two parts that are the same, it gives me an isosceles triangle. And remember, isosceles triangles have two congruent sides, but also two congruent angles. So I have a second angle on the other side of this triangle that is also 8x plus 4. And now notice that my orange angle and my green angle both make up one angle on the side of this rectangle. And rectangles have right angles in their corners. They are similar to squares in that way, and we'll get to squares in a bit too, but rectangles are more stretched out than squares. So if that's a right angle, that means that those two angles have to add up to 90 because there's 90 degrees in a rectangle, or a right angle. So 3x minus 2, my green angle, or 3x minus 2 plus 8x plus 4 has to add up to 90 because they make a right angle. I'm going to combine my like terms. I've got a 3x here and an 8x there. When I add those together, I get 11x. And then I've got a -2 and a +4, and that simplifies to a +2 equals 90. I'm going to subtract 2 from both sides. So 11x equals 88. Divide by 11, and I get x equals 8. Okay, next problem. Another guided practice. I've got another rectangle and another angle that they give me. With this one is FGE. FGE is this angle right here, and it tells me that that angle is 6x minus 5. And then I have another angle, 4x minus HFE. HFE is this one, which is 4x minus 5. So again, I've got another isosceles triangle. I'm going to quickly highlight it here. Bam. With two congruent sides here, which means that my two angles that are the same are these two. So this one is also 6x minus 5. And this has to make a right angle in the corner. So I'm going to add those together and set them equal to 90. So 6x minus 5 plus 4x minus 5 has to equal 90 because they make up a 90-degree angle. I'm going to combine my like terms. I've got 6x here and 4x here. Combine those and I get 10x. And then I have a minus 5. Minus 5 and minus 5, which is minus 10 equals 90. I'm going to add 10 to both sides. So 10x is equal to 100. Divide by 10. Divide by 10. X is equal to 10. Boom, 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 boom. Great. Okay, moving on. We got another theorem here. This one says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if we see congruent diagonals, we can right away say that that shape is a rectangle. So that'll be useful when we're trying to prove that a shape is a rectangle. Okay, we've got a word problem here. This one's about art. Some artists stretch their own canvas over wooden frames. This allows them to customize the size of a canvas. In order to ensure that the frame is rectangular before stretching the canvas, an artist measures the sides and the diagonals of the frame. If AB equals 12 inches, okay, let me start labeling. AB equals 12, so AB is this top side. And BC, which is the side, right side, is 35. CD is 12. And DA is 35. Okay, so far we've got all of our outer edges. Next, it tells us that BD, this one right here, is 37. And that AC is also 37. And we have to explain how the artist can be sure that it's a rectangle. Well, based on that last theorem, since the diagonals are congruent, then it's a rectangle. Great. Moving on down, another word problem. Max is building a swimming pool in his backyard, and he measures the length and the width of the pool so that the opposite sides are parallel. And he also measures the diagonals of the pool to make sure that they are congruent. How does he know that the measure of each is 90? Each corner is 90. Well, if the diagonals are congruent, then the shape is a rectangle. I'm going to abbreviate. Then the shape is a rectangle. And rectangles have right angles. Basically, if it's a rectangle, then it's got to have right angles. So, of course, the corners are going to be 90 degrees. Okay. Another example, a rectangular park has two walking paths down that are shown here. If PS would be this side here, that is 180 meters. And PR is this one, that is 200 meters. And we need to find QT. QT is, this length right here. Okay, so the way we're going to do that is we are going to find the length of the diagonal, the missing diagonal, the whole thing. I'm going to find the length of that. We're going to do that using the Pythagorean Theorem because this is a right angle. We know that because it's a rectangle. So let's use the Pythagorean Theorem. The Pythagorean Theorem is a squared plus b squared equals c squared. Key is, what's our a, what's our b, what's our c? So our a and b are our two shorter sides. In this case, our a and b will be 180 and 200. 180, 200. So I'm going to plug those into my problem. I get 180 squared plus b squared, which is 200 squared, equals our missing side c squared. And I know that that is my c squared because it is opposite my right angle. So let me quickly do those calculations. 180 squared is 300, or not 300, 32,400. We're going to add that to 200 squared, which is 40,000. And we're going to find c squared that way. So let me add those together. And I got 72,400. We're going to square root c squared to get c by itself. So I get c equals whatever that is. So c equals about, I'm going to change those to little squiggles, about 269 meters. So that's our missing diagonal. But keep in mind, we're not trying to find that length. We're trying to find half of that length because this half is equal to this half if we were to cut those in half. So half of that divided by 2 is, so QT is half of that, which is 134.5. Okay, next, this one says that angle PRS, which is this angle right here, is 64 degrees. And we need to find SQR, which is this angle. This angle right here. So remember that this angle and this angle are the same because this is an isosceles triangle, which means that those base angles are the same. So those two angles have to make up a right angle. So they need to add together. Remember what that's called? That's called complementary angles. Add up to 90. Subtract 64. I get x has to equal, what is that, 26? Okay, number 3, this one we are told that TS, which is this length from the middle down to S, is 120 meters. And we need to find PR, which is the whole other diagonal there. That's a terrible line. Okay, so remember that the halves are the same, which means if that half is 120, then this half is 120. That's a terrible color to use on this. This half is 120, and this half is also 120, which means that T or PR, the whole thing, is equal to 120 plus 120, which is 240. Okay, we've got another graphing problem. So this one, it tells us that the vertices are at -2, -3. So let's go ahead and graph that really quick. -2, or not -2, -3, -2, +3, which is right here. That's J. K is at 1, 4, 1, 2, 3, 4. L is at 3, -2. And M is at 0, -3, which is right here. We have to determine whether JKLM is a rectangle using the slopes of these points. So let's try and find our slopes. And remember, this should be a parallelogram, which means that the slopes should be parallel to each other. So let's check these two, make sure that they're parallel. This slope, remember that slope is rise over run. So I'm going to check how much it rises and then how much it runs, which is how much it goes over. So it rises, in this one, it rises 1. 1, it goes over 3. So the slope of JK is 1, 3. Now let's check M and L. Does it go up 1 over 3? Yes. So ML also has a slope of 1, 3. So far, so good. They're both parallel to each other. Now let's check this one. JM. So this one, we're going to go down into the right just because I don't want to overlap. So let's go down 1, 2, 3, 4, 5, 6. So we went down 6 over 2. So that slope is negative 6 over 2, which simplifies to negative 3. Now do it again. Go on over on KL. Let's go up 1, 2, 3, 4, 5, 6. So we went up 6 this time, and this time we're going left 2, which is negative 2. Let me change that. I'm going to change it to JM. And KL is negative 6 over 2 again, which simplifies to negative 3. Okay, again, the sides are all parallel to each other, so that's a good start. Now, to make sure that it's going to be a rectangle, I need to make sure that the angles have right angles in the middle. If the angles are right angles, I know I'm good. How I'll know that they're right angles is I'll check to make sure that those slopes are perpendicular to each other. So perpendicular slopes, remember, is the opposite reciprocal. So opposite means positive to negative, and reciprocal means you have a fraction like x over y, and it becomes y over x. So you flip it. So let's take a look at my slope. I'm going to check this one and find the opposite reciprocal. And then if the other one matches, I know I'm good. So the opposite reciprocal of 1/3, so 1/3 is positive. So my new slope is going to be negative. And the reciprocal means I need to change the places top and bottom. So 3 over 1, which simplifies to negative 3. Does that match my negative 3 slopes here? Yes. So this is a rectangle. Great. Okay, last problem. We've got another quadrilateral with these vertices. Let's go ahead and graph those. So W is at negative 2, 1, which is right here, W. X is at negative 1, 3, which is right here. Y is at 3, 1. And Z is at 2, negative 1. Connect those dots. So this one says to check to make sure it's a rectangle by using the distance formula. So remember that it'll be a rectangle if the diagonals are the same. So let's go ahead and check those diagonals using the distance formula. So the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Oop. So that's the distance formula, and we're going to check the distances between our diagonals. So let's check x and z. So the distance between x and z, or really quick, let's write those down. X is negative 1, 3, and z is 2, negative 1. So I'm going to make x my x1, y1, and z my x2, y2. Plug those into my formula. So x1 is negative 1 minus x2, which is 2 squared, minus or plus y1, which is, plus y1, which is 3, minus y2, which is negative 1 squared. Okay, let's go ahead and simplify this. I'm going to start with my parentheses. So first, negative 1 minus 2 is negative 3, plus 3 minus a negative 1 is 4, positive 4. Negative 3 squared is 9, plus 4 is, or 4 squared is 16. So 9 plus 16 is square root of 25. Simplified, that is just 5. So the distance between x and z, or this diagonal, is 5. Okay, now let's do it again, but this time we're going to find the distance between y, or w and y. So w is at point negative 2, 1, and y is at 3, 1. So let's plug those into my distance formula. I'm going to make this one x1, y1, x2, y2. Distance formula, bam. First it'll be x1, which is minus 2, minus x2, which is 3, squared, plus y1, which is 1, minus y2, which is 1, squared. So negative 2 minus 3 is negative 5 squared, plus 1 minus 1 is 0 squared. Well, negative 5 squared is 25, plus 0 doesn't really do anything, so it's just 25. Which is, again, 5. So those distances are the same. So this is a rectangle. Is a rectangle. Because the diagonals are the same. Okay, great. We are done with day 3, rectangles. So I'll see you guys all again for day 4.